So this is FRQ 2022 question. Let me explain this question for you. Uh, Two blocks are connected by a string that passes over pulley. So these are two blocks which are connected by a string. Block 1 is on horizontal surface. So this is block 1, of course, on horizontal surface. And initially, the spring is unstretched. So this spring, which is connected to M1, is unstretched. It implies no force is exerted by this spring on this block. Friction forces are negligible. Whenever I see this statement, I think attempting question in terms of energy conservation. Of course, so there is no frictional force between surfaces as well as pulley axle. Now block 2 is released. So this block has been released from rest and it moves downwards and finally comes to rest momentarily. Now let's see what is asked in question number 1, part A. They are saying that block 2 starts from rest. Okay, so it starts from rest, then it speeds up and then slows down, coming to rest. In terms of only forces directly exerted on block 2, explain why block 2 initially speeds up and why it slows down. So we have to explain why it speeds up and then slows down, finally coming to rest. So if you draw free body diagram of M2, I can say two forces are acting on this block. One is gravitational force, which is M2G. Another is tension force. So initially, tension force is smaller and gravitational force is larger. So net force is acting on this block in downward direction. So it should be accelerated in downward direction. So you have to state that in the direction of net force, there is acceleration. So this block is accelerated in downward direction. So its velocity should increase. So we have answered why its velocity increases. But when it moves down, there is elongation in the spring. So spring will start exerting more force on this block of mass M1. As a result, tension in this string increases. So when tension increases and it becomes greater than M2G, this accelerated motion becomes a retarded motion. Now this block slows down and finally comes to rest. So I have written whatever I have explained here. You can have an eye over it. Now let's see another part. They are saying derive an expression for distance delta y the block 2 travels before coming to rest. So how much distance is traveled by this block before coming to rest? We have to answer it. Okay, so first we have to uh, write the energy conservation equation that will give us point. But before that, you have to tell that since friction is absent, we can apply energy conservation. So let's see how we are writing this energy conservation equation. So I am assuming at this horizontal level, potential energy is zero. And let this distance be equal to h1. So initially, this spring is unstretched. If this spring is unstretched, its potential energy is zero. This block is on zero reference line, so its potential energy is also zero. But this block is below reference line by distance h1, so its potential energy will be negative. So this is m2g. Since it is below, I am writing minus h1. So this is initial potential energy of my system, which consists of this spring, this block, this block. Of course, you can assume tension as well as earth. Why earth? Because you are writing potential energy of this block. So potential energy of this block, you are saying it is m2g minus h1. right? So potential energy is due to configuration of Earth and this block. So potential energy doesn't belong to only this block. It is interaction of this block with Earth. So whenever I write potential energy of this block, I have assumed Earth to be my system. Okay. Now let's see. This is initial energy. Let's see what is final energy. So after some time, when this M2 has reached at this point, a spring would have stretched by delta V. So what is energy in spring? Half K delta Y square. Potential energy of block will not change, while potential energy of this M2 will be M2G. And now how much below is that M2 from a reference line? It is H1 plus delta Y. This is H1 plus delta Y. So I have written it, of course, with negative sign. So once you write this equation, you will be awarded 1 point. And then after solving it, another point you can earn. So delta Y comes out to be twice M2G by K. Now let's see what is another part. Okay. So in this part, they are saying that whether the mechanical energy of a spring, a block, and earth system changes or it remains constant. So I have already answered it that all the surfaces are frictionless and there is no other non-conservative force. So we can say that mechanical energy will be conserved. So I can say it will not change, it will be conserved, right? And now coming to last part of this question. Now let me explain this question first. Consider system that includes a spring, earth, and both block and spring, but not surface. Okay, so our system consists of a spring, earth, and both the blocks, but they have excluded the surface. And initially, blocks are at rest, and in final state also, the block comes to rest. So these are diagrams which represent energies of our system. So what is US? It is potential energy of spring. And what is UG? It is gravitational potential energy of Earth block system. So this is mu G, right? So obviously, initially, that spring is unstretched, so its energy should be zero. Let me explain it here. Initially, this spring was unstretched, so its energy was zero. So potential energy of spring was zero. And I am assuming that potential energy of this M1 and M2, let it be equal to 4 units. So gravitational potential energy is 1, 2, 3, 4. Total 4 units. So in the absence of friction, where we can say energy is conserved, I can say that initial energy will be equal to final energy. So when this block moves down, its potential energy decreases. When it comes to rest, I can assume its potential energy is zero. So gravitational potential energy here is zero. But at the same time, its spring has stretched by certain amount. So whatever is the loss of potential energy here will be gain of potential energy of spring. So potential energy of spring while will rise by 1, 2, 3, 4, total 4 units. So initially was it was also 4 units. Finally, it was also 4 units. So this is what they have given. And now they are saying what will happen if there is some friction between the surfaces in contact. Okay, so of course, if there is friction, there will be loss of energy. So initial energy, which was 4 unit, will not be 4 unit now, there will be some loss of energy in the form of heat. So, of course, I have represented it here. Due to friction, now this block will not be able to move the distance which it has moved in the absence of friction. So now the energy stored in spring will be less. So instead of 4 units, I am assuming that energy to be 2 units. So now potential energy of spring will be 2 units, right? Just because of friction, this block was not able to move towards right by the distance it has moved earlier. And also, this block M2 will not lose all its potential energy as it has lost in the absence of friction. So now this block will also have some energy, and therefore I am representing it by 1 unit. So now total energy is 3 unit, and I can assume that there is a loss of 1 unit energy here. So I have taken all this just for the sake of explaining. So at last, I can say that initially energy was say 4 unit. In the absence of friction, energy will also be 4 unit. But when there is frictional force, energy will be decreased. And here, energy, total energy, I have assumed it to be 3 units.